All right, you are welcome again. Today, let's take a look at this particular question. Evaluate the integral of dx all over 2 plus x in bracket 1 plus ln 2 plus x. Okay, so we are asked to evaluate this particular integral. It's very simple. Please pay attention and see the step by step on how to go about this question. Okay, solution. Now, look at this. We have the integral of dx all over 2 plus x in bracket, open another bracket, 1 plus ln 2 plus x, close the bracket. So what do we need to do? We are going to a kind of factor, okay? Bring out the factors here. Or we are going to rewrite it. Now, if you are to write it, look at how it's going to be. Look at how we can decide to write it. We can decide to say that it's like this. The integral of 1 all over 1 plus ln 2 plus x times dx all over 2 plus x. And you will agree with me that we've not done anything magical, or we've not done anything here, right? So this particular expression is the same as the original question, right? Yes. So here we have the integral of 1 all over 1 plus ln 2 plus x times dx all over 2 plus x. So when you multiply this, it's going to give you the same thing as the above. So we can now go ahead and integrate. So we're going to use substitution method. So here we're going to say let u equal to 1 plus ln 2 plus x. Okay? This 1 plus ln 2 plus x, let's call it a letter u. And now you can see that this u is a function of x. So we differentiate u with respect to x. Okay? Yes. But before we differentiate this u with respect to x, you can see that we have ln 2 plus x is a bit complex. So we cannot differentiate this straight up. So we are going to apply chain rule to differentiate this. I don't know if you get what I'm trying to say. Now, this u is not simple to be differentiated straightforward. So we are going to apply chain rule to differentiate it. So applying chain rule, we are going to say let this content of this bracket, here we have ln 2 plus x. Had it been is just something like maybe ln x, to be very simple, but here we are having 2 plus x. So we're going to say let the content of this bracket, which is 2 plus x, let's call it a letter so that it will be simple for us. Let's call it a letter t. So we're going to say let t equal to 2 plus x. I'm talking about this u, which is equal to 1 plus ln 2 plus x. So we call 2 plus x a letter t. Now t is a function of x. We differentiate t with respect to x. So when we find the t all over the x, it's going to give us 1. Look at it carefully. When we differentiate 2, it's going to give us 0 because it's a constant. And when we differentiate x, it's going to give us 1. Are we together? Okay, good. You remember how we go about chain rule in differentiation. Now you hold your dt all over the x. Good. Now let's go back to u. We said that u is 1 plus ln 2 plus x. And we just made a substitution where we say t is what? 2 plus x. Okay, we are renaming our variable now. So that means this 2 plus x can be replaced with the new value we have, which is t. So here we are going to have u is equal to 1 plus ln t. Do you get this? Yes. Now, u is now a function of t, not x, like the initial. So we are going to differentiate the u with respect to t, not with respect to x, because it's not a function of x. Now let's differentiate. That means we're going to have du dt. So when we differentiate du dt, it's going to give us 1 all over t. Because when you differentiate 1, it's going to give you 0 because it's a constant. And when we differentiate ln t, it's going to give you 1 all over t. Are we together? Yes. Now, remember, we have u is equal to 1 plus ln 2 plus x. U is a function of x here, and we are looking for du dt. But the two derivatives we have here is the t dx and the u dt. And we say we are applying chain rule. So chain rule here now is saying that for us to find the du dx that we are looking for, we should multiply the two derivatives we have now, we just obtained. Okay, so that is to say that we are interested in getting du dx, not the u dt or the t dx. So the chain rule properly say du dx that we're looking for is the product of these two derivatives, which is du all over the t times the t all over the x. Okay, now let's apply it here. We have du dx is equal to du dt is 1 all over t times dt dx is what? Is 1. Okay, so which is the same as saying 1 all over t. Recall that t is equal to 2 plus x. Can we replace it here? Yes. That means du dx is equal to 1 all over 2 plus x. Right? Yes. Can we cross multiply? Yes. Let's cross multiply. When we cross multiply, we're going to have 2 plus x du is equal to dx. 2 plus x du is equal to dx. Now, let's go to our original problem, or the question we have from the beginning. We have the integral of 1 all over 1 plus ln 2 plus x times dx all over 2 plus x. Remember, we just say let this denominator where we have 1 plus ln 2 plus x be called a letter u. Are we together? So we are going to replace this 1 plus ln 2 plus x with a letter u. What is going to happen to dx all over 2 plus x? Let's try and see if we can bring out this dx all over 2 plus x with what we have here now. Here we have 2 plus x du is equal to dx. Okay, let's see if we can make du the subject. So here we have 2 plus x du, which is equal to dx. Divide both sides by 2 plus x. When we divide to make du the subject, we are going to have du is dx all over 2 plus x. From the original question, we are having dx all over 2 plus x. And here we are also having dx all over 2 plus x. So that means the x all over 2 plus x can be replaced with du. Okay? So let's go. Here we have the integral of 1 all over 1 plus ln 2 plus x times dx all over 2 plus x. Let's make our proper substitution. Remember, we say let 1 plus ln 2 plus x be called the letter u, right? Let's replace it here. We're going to have the integral of 1 all over u times. You remember we just solved and we see that dx all over 2 plus x is the same as du. Now we're going to replace it du. Okay? Yes, here we have the integral of 1 all over u du. Let's integrate properly. So integrating is going to give us ln u plus c. Integrating is going to give us what? Ln u plus c. But remember our initial substitution, or calling a variable. We say let u equal to 1 plus ln 2 plus x. You know, we declare this variable initially, right? So let's replace u now with the value, which is 1 plus ln 2 plus x. So replacing, you are going to have ln, open bracket, 1 plus ln 2 plus x, close the bracket, plus c. Hello. Do you get this? Yes, it's actually very simple. So we started and we make our question to be simple for us, right? Then we start to declare a variable u to be what? 1 plus ln 2 plus x. Are we together? And then trying to solve u with respect to x, that is the u dx. And then we apply chain rule. Okay, and then we say let t equal to 2 plus x, and then we solved. Then properly solving the u dx, applying chain rule, we obtained du dx is equal to 1 all over 2 plus x. Then we cross multiply and make du the subject. And we discover that we found dx all over 2 plus x from the solution we got. Now we go ahead and make the substitution clearly from the variable we declared. We substitute now, and then which is u. So 1 plus ln 2 plus x is being substituted by what? U. And then dx all over 2 plus x is being substituted by du. And then we integrate. We have ln u plus c. Then the variable we declared from the beginning, we bring back the value. Okay? So we say u is equal to 1 plus ln 2 plus x. We bring the value back. Then we have ln 1 plus ln 2 plus x in bracket plus c. Yes, so this is the solution. Thank you very much for watching. Please, I want you to search for more integration problem. We have solved so many of them. Okay, watch them all over and all over again, and make sure you are taking notes. Don't just watch them without solving them yourself. Okay, yes, thank you very much. Please like our videos, share, and don't forget to subscribe. Stay blessed. Let's take more examples.